Hi class, it's Bill Berry here with an introduction to designing a database. We have dabbled a little bit with some of our projects in design, but we haven't really started from scratch and looked at how we can create a database and take client artifacts, information that comes from clients, and try to shape that into something that'll work in a database environment. So that's what we're going to do today, and we definitely are turning the corner from data manipulation language, DML, to DDL, data definition language. We're not going to write the actual SQL that does that, but we're going to get really close. We're going to talk about how we can mold the data to fit into a database, and then in another video we're going to talk about how to create an EER using MySQL Workbench. And so let's get started with the designing a database piece. So let's see, what are we going to talk about? Designing a normalization, so let's start with that. At first, when you talk to a client, there's going to be very often some artifacts that they will present. You'll say, show me how you do your work. Tell me how your workflow goes. Show me the kinds of documents that you're thinking about that you're going to want to put the data into a database. And there's often going to be a lot of information, and sometimes the clients have a specific thing in mind that they believe is going to help organize, but in truth it may be that the database, to get a true relational database, requires things to be in a little different format. So some of the hints that we're going to do, some of the things we do at first, are we're going to try to separate out entities, right? Very often the client has them all munged together, overlapping each other, but we have to separate things out. That we just know that different entities need different tables, so that's a starting point. We're also going to keep a keen eye out for repeated data. Repeated data is not our friend. It causes problems when we have to insert, update various manipulations of a database, so really repeated data is not something that we want to see. We also want to think about primary keys. We know that the world goes around based on keys, so we always want to keep in mind, is there a natural primary key for this data? Do we need to make one up, etc.? And then all of this is going to be part of a technical concept called normalization. So we're going to talk a little bit about that, but we're not going to spend a lot of time fussing over it because I want us to get sort of a sense of how it works, and a lot of it will kind of feel natural and will seem right as we go, but we will talk about some of the normalization forms just so we're clear and you know what to expect in that when you see it in the future. So normalization is taking the data that is in a form that is going to present problems in a database because of difficulty maintaining data, inserting, updating, etc. We know that we need to separate things out, but there's some specific things that you can do, and they are called normalization. And there's a whole science behind this, and there are 7 normal forms, starting with first normal form, 1NF is the abbreviation, and starting there are a whole bunch of normal forms that are sort of known ways that we can take data and put it into a form that is going to be very database friendly. We're going to study mostly the first 3 forms because those are the ones that almost everyone agrees are necessary, and then there are certainly more forms that you can study. There's references if you want to dive into that, but we're going to spend our time here. One of the things you can think of is this little catchphrase: normalization, first 3 normal forms, the key, the whole key, and nothing but the key. Oops, that should say but. Those are our typical kinds of rules. So first normal form says get different entities into separate tables. That seems obvious. Next is make a PK, right? Figure out what the primary key is going to be. Then make sure that every cell of data is atomic. In other words, there's no repetitions of data within one cell. It's one piece of information per cell. And then we also eliminate columns that tend to repeat. So where there are repetitions built into different columns, that's also something that we don't want. So first normal form covers a whole bunch, and that will be our first step. Second normal form starts to get more particular about the primary key. If you have a composite key and you have columns that depend on only part of that, only one part of the composite primary key, those need to move out as well, right? Things need to depend on the entire key, not just part of it. And third normal form, we're going to eliminate columns that don't depend just on the key alone. In other words, if there are columns that depend on other columns that depend on the primary key. All right, so sometimes there's these sort of secondary relationships called transitive dependencies, and those are going to need to be eliminated as well. Now, normalization can go a long way. In fact, you can sort of go down the rabbit hole of normalizing and going crazy. And there are times when you realize that you've gone like a little past the edge of sanity when it comes to working with your data. It's going to take joining to do anything useful. And there are times when you kind of pull back from that normalization, and that is called denormalization, right? So if you, there are cases where you say, yes, this would be proper, but it's more work. I realize that it's maybe going to take a little more work to maintain my data, but I'm willing to take that risk because it's going to make my life easier. So there's normalization, and then there's pulling back from that edge. But the first three forms, I think we can all agree, those are generally pretty good things to keep in mind, and denormalization generally comes past that point. So let me give a quick introduction to the problem that we're going to tackle, and then we'll probably kind of break the video there and actually jump into the design portion in a separate video. So let's say that you are working with a particular group. In this case, maybe it's a parent Student Teacher Association, PTSA, Parent Teacher Student Association. And they are interested in getting a database, and they present you with this data. Now notice here I'm just using Microsoft Word. We don't really care about the tools because this isn't a tool question at this point. This is a thought question. So for this part, I'm just going to use Microsoft Word, and we're just going to work with the data and understand how that goes before we get into the details of implementing it in MySQL, drawing an EER, blah, blah, blah. That's all coming later. So for the moment, let's just take a look at the data and let's see if we can identify any problems that kind of jump out at us. As we're looking through this data, we have a member name, great. We have a phone number. We have a zip code of where they live. We have an office. Well, that's kind of interesting. Notice that this person was a president, and what does the 16 mean? You might ask them, oh, that's 2016. Pat was a president in 2016, whereas Chris was the president in 2015. Ah, well, this data looks kind of like maybe it represents a separate entity, right? The office, a role or an office for this particular group feels kind of like it's a separate entity, and then this number goes along with it. One problem is this is kind of two pieces of information in one cell, so we know that's not right. And also the fact that president is repeated over and over, that gives us a clue. That's kind of a repetition that we might want to eliminate. So there's definitely something that we might want to do with the offices when we get to a later stage. Another question, let's see, look over here with committees. Okay, so we see several things that are a little bit of a red flag for us. First, we have these places where two different committees are mentioned in one cell. So Pat was on the recruitment committee and joined that particular date, and was on the annual party committee and joined that particular date. So we see that within this one cell, again, there's a repetition of the name of the committee, but then we also have this multi-value thing where we have not only the name of the committee, but also the date. So that's two pieces of information in one cell. So there's several things that jump out at us here as needing work. So certainly committees are going to be another place where we can spend some time and figure out what to do. Then our probably most difficult piece comes over here in the dues. You'll notice that right here we have the 2016 dues, here we have the 2015 dues, and we're guessing that there's going to be another thing that has 2017, 2018, 2019. So you'll see here that you've repeated the whole idea in multiple columns. So you know that's not right, right? That's that idea of multiple columns that contain sort of repetitive types of things. So that doesn't seem right. Also, again here we have two pieces of data in each cell. We have a dues amount or a payment toward the dues, and then we have the date that that was made. So that's, again, non-scalar, right? There's two pieces of information in one cell. We know that's not right. Then again, we have this concept, this problem where we have repetitions, right? So Pat on 1/5 gave $10, and then on 1/19 gave $10 more. So this has several problems: repeated columns, repeated entries, multiple pieces of information per cell. Wow, all of that stuff is messy, right? So definitely we need work. Then we've got this thing over here, which at first looks a little puzzling, and you might ask them, like, what's that $20 sitting here for? And they would respond, oh, that's how much the dues were for that year. In 2015, it was just $15, but in 2016, it was $20. Oh, that's the amount of dues that were due for that year. Okay, so we have a bunch of interesting things to deal with, but definitely these two columns definitely have some work to go as well. We also have some things that are kind of subtle. For instance, why does Chris have nothing in this cell, but Marty in this cell says NA? So again, you might have to go back to the client and say, what does that mean? What does NA mean? And they say, oh, Marty didn't owe any dues because Marty wasn't a member in 2015. So therefore, no dues were actually owed. Wow, okay, so now we have yet another little piece of information that we have to assimilate here. We have this idea here that if there's nothing in the cell, it's something that we need to, they still owe the money, they haven't paid, but if it's NA, they didn't owe the money to begin with. So now we have this several interesting things to deal with. So in the next video, we need to pick up and start tackling all of these problems that we see here. So pick up with that video and we'll see you back at that point.